All right, today we're going to talk about estimating sums and differences. So, the first thing I want to talk about with you guys is the word estimation and what that's going to mean in fifth grade. And so, when you estimate numbers, you're really thinking about finding numbers that are close, or maybe thinking about friendly numbers that are easy to use in your head. So a lot of times I might talk about with my students, thinking about numbers that have fives or numbers that have zeros or tens, because generally those are the ones that are a little bit easier to use. Um, a lot of times when estimation is brought up, kids do think about rounding, and so rounding is something that has a lot of similarities with estimation, but a lot of times when you round, you're rounding to a specific place. Whereas when you estimate, you might estimate and have more of, a little bit more options. You might estimate to the nearest whole number. You might estimate to the nearest, cent. You might estimate to the nearest benchmark number. So there's a lot of different things that could come into play when you estimate. And a lot of times you could have answers that are pretty close and you're just looking for like the best possible answer. So I'm going to show a couple of things here. I'm just going to give some practice problems and then we're going to talk about sums and differences. So I'm going to start with this problem first. I'm going to write 3 and 92 hundredths plus, let's do plus 2 and 3 hundredths. Okay, so looking at this problem, first of all, if we were going to estimate this problem, what we would want to start by thinking about is, okay, well, how can we make this problem easier for us? How can we use estimation and change our numbers here to make this problem easier? And so when I look at this problem, there's a couple of things that go through my head. First of all, I didn't put dollar signs here, but a lot of times in my classroom, I tell kids, well, especially with decimals, think about money, think about things that you could think about out in the real world. So this could look a lot like $3.92 plus $2.03. Well, if this were out in the real world and it was money, a lot of times people wouldn't go, okay, well, I'm going to go add $3.92 plus $2.03. They're probably going to say, well, $3.92 is pretty much 4, and $2.03 is pretty much just 2. So I'm going to estimate this to be around 6, or if it was money, to be around $6. Now, that's not your actual answer, but it's something that's close. And again, when you estimate, that's kind of what's going through your mind. You want to get something that's close. You want to get, use easy numbers, friendly numbers, things that are easy to work with in your head. And so on this particular problem, I could say, well, 4 plus 2 is a really good estimation because 4 and 2 are really close. And really, there, somebody might go, well, okay, I see what you did. You just kind of rounded it to the nearest whole number, which is true. That's what I did. But in my mind, I kind of just changed it to money because I thought money might be an easier way to see it. Okay, so on this next page, I want to look at a different problem. I want to look at, let's do 16 and 341 thousandths minus 3 and 92 hundredths. And so looking at this, if I had this problem pop up and it was an estimation problem, there might be a couple things that would go through my head. I might go, okay, well, let's look at this again. Let's think about our numbers here. Well, I have 16 and 341 thousandths. If I had that number and I really understood what that number means, I know that this number falls somewhere between 16 and 17 on the number line. But because it is 16 and 3 as you're in your tenths place, 16 and 341 thousandths, but that 3 in my tenths place there, I might go, well, okay, you know what? It's still pretty close to 16. It's, it's not too far past the number 16 on the number line. And so if I really wanted to, I could just call this 16. And then I could subtract, and then again, 3 and 92 hundredths, looking at this, I might go back to money. I might say, well, $3.92, that's pretty close to 4, and I can come up with this problem of 16 minus 4. And a lot of times, again, when you're estimating, you want to make it easy on yourself, something that you could do mentally that just not going to cause a lot of stress or anything. You can just sit there and you could do this problem in your head. So if I did 16 take away 4, yeah, again, pretty easy math problem there. You would end up with the answer of 12 and say, okay, well, hey, I can estimate this original problem and say it's going to be pretty close to 12. Okay, on this page, I just took some problems out of the book. There is something here that I want to talk about on this page because it is a vocabulary word that you might see a few times in your 5th grade year. This particular one, the instructions say use rounding or benchmarks to estimate. Let's talk about benchmarks real quick. So benchmarks are numbers. You might see it now when we talk about decimals. You also might see the word benchmarks come up when we talk about fractions. We do a whole lesson when we talk about benchmark fractions. A lot of time benchmark numbers are your numbers that are, again, they're friendly, they're easy to work with. They're numbers that you see a lot out in the real world. And so when it comes to decimals, a lot of times I tell kids to think about your quarters, like counting up by quarters. So again, kind of relating it back to money, you ought to be able to count up by quarters in your head. And when you see a problem, you might think, okay, well, what's the closest quarter that it could be at? In other words, if you're looking at a number and let's just say the number was, I don't know, maybe 7 and 85 hundredths. Well, 7 and 85 hundredths, you could think, well, that's like $7.85. Well, $7.85, I could go, well, the closest quarter to that, I might could drop it down to 7 and 75 hundredths. And so, again, it's just kind of a mindset to get into when you see benchmark numbers to think, what are those friendly numbers that I can use in my head? I could maybe calculate it using mental math. And again, if it's going to be an estimation, we're looking for something that's close. It's not going to be exact. We want a close answer. So let's try some of these on this page. So I'm going to start with number 6. Number 6 is an addition problem. It's already set up for you. If it's saying use rounding or benchmarks to estimate, I don't want to go take this problem and solve it. I don't want to do 93 hundredths plus 18 hundredths. I want to use some benchmarks here. So what I look at again, I might think of, okay, 93 hundredths. 93 hundredths is really close to 1 whole. And so next to this problem, I could just simply write 1. And I could think, okay, that's pretty close to what it is. If it's money, 93 cents is pretty close to $1. And then I could look at the next one of 18 hundredths, and I could do a couple of things here. This is kind of what I meant earlier by estimation. You can, it's kind of that closest answer, which whenever is going to be closest to it, that's going to make more sense to you. And so when I look at it and I see 18 hundredths, 18 hundredths is a really small number. And so I could think of it a couple different ways. I could think of 18 hundredths being, well, I could really just call this, if I said, hey, let's round this, I can maybe round it back down to 0 and think, okay, this problem really could just be 1 plus 0. If I wanted to be more specific and maybe estimate it a little differently, I could call 18 hundredths 20 cents. So I could call it 0.2, or in this case it would be 2 tenths or 20 hundredths. Either one would be the same. And then I could put the 1 back up that I had previously and say, okay, well, I could also add this up and I can get 1 and 20 hundredths versus my first one, which would have just been 1. And when you're estimating, those two things aren't that far apart. 1 versus 1 and 20 hundredths, those are really close to one another. All right, so the next one here is going to be 8 and 12 hundredths plus 5 and 52 hundredths. I'm going to go a little bit quicker here. I feel like if you're using benchmarks or if you're using rounding, you would say, okay, 8 and 1200ths is really close to 8. And then 5 and 5200ths, that's really close to 5. And then I'm going to go back to that quarter conversation. This is the benchmark here that I think they would be going for. I think that's pretty close to 5 and 50 hundredths, or what would basically just be $5.50, or you could actually call this 5.5, because that's what 50 hundredths really is. It's just a half. And so, since this is an addition problem, you can add up your whole numbers there. You have 13, and then I'm just going to keep the 50 hundredths and have that as my answer. The last one I'm going to pull down to the bottom and work. It's a subtraction problem. You have 9 and 75 hundredths minus 3 and 47 hundredths. And so here you have a couple of options. Again, you could go for, think money, $9.75. You could think $3.47. You could use benchmarks here. It's really up to you, however you see it. I feel like a good one to start with could be, let's call 9 and 75 hundredths. Why can't we call that 10? That's pretty close to 10. And then if it's 3 and 47 hundredths, that's kind of, you're kind of close to being like right there on the, like right in the middle. And so I would be okay if this were my class. I'd be okay if a kid called this 3, or if they called it 3 and 50 hundredths. So either one of those would be fine with me. You could get really specific here, and you can, again, that's kind of the issue with when you get into estimation. You got to think, what is your best answer choice? What is your best solution? And so either one of these would be fine. You could do 10, take away 3, and you could get 7. Or you could you could start with 10 and take away 3 and 50 hundredths. And you could think about, okay, well, that's going to be a little bit less than 7. This would drop you down to 6 and 50 hundredths. And again, didn't have to go and solve this out traditionally. It was something I could do mentally. And again, that's kind of where you're going with estimation. You want to try to do this quick, easy math. You want to get something that's close. All right, couple problems here out of the book that were multiple choice. Let's go over these. So I'm going to read question 16. Danielle and Raj want to combine their money to buy a soccer ball. Danielle has $7.95. Raj has $6.35. Which benchmarks should they use to estimate the money they have? All right, so let's talk about a couple of things here. First of all, I'm going to circle Danielle's amount. She's got $7.95. When I first read that, especially when it said the word estimate, I'm thinking, you know what? I'm probably just going to call that $8. That is 5 cents away from $8. And then Raj has $6.35, so I'm going to circle that. And then, that's kind of one of those where you might stop and think, okay, what is that really close to? So I'm going to write it down here, $6.35. If I was using, benchmark numbers, I could think, well, all right, that's pretty close to $6.25. It's also, a kid might argue and say, well, it's getting pretty close to $6.50 as well. So that could be an option. So I'm going to kind of just leave it up to my answer choices. And I want to try to find the one that's best. Again, a lot of times that'll be the wording on these questions. What is the best estimate? And so looking through these, a couple of things here crossed my mind. Considering that Danielle has $7.95, it being that it's 5 cents away from 8, this is what's really kind of on my mind when I go to these answer choices, because there's really only one here that has 8. So if I look at it and I compare it to the other number, $6.25, that was one of the ones that I had for Raj. So the best answer choice here, I feel like, should be B. And I didn't have to go and add or anything here. I just had to know which ones were the correct benchmark numbers. And so, again, on these problems, you really have to just, stop and think about what estimation means, think about what are the best numbers possible for whatever the situation is. All right, this last one is multi-step. Jesse, Max, and Khalil each ate 32 hundredths of a pizza pie. Which number shows the best estimate of how much of the pie they ate together? And so, a couple of things here that it sticks out to me. It says best estimate. So I'm already thinking in my mind, I'm going to be estimating here. And then when I read this question, I'm thinking which number shows the best estimate of how much pie they ate together. I really think I'm going to be combining here. And so I have Jesse, Max, and Khalil each ate 3,200. So I'm going to write 3,200s out to the side. And I'm going to think, okay, what could I use here as an estimation? Well, 3,200s is, there's a couple different ways I could go with this. 3,200s is pretty much, it's 200s off from being 30 hundredths, or just 3.3. 3/10 or 30 hundredths would be the same. And so when I look at this problem, kind of thinking about what I could do as a mental math, something that's quick and easy, I could think of it as being, okay, really this is just 3/10 plus 3/10 plus 3/10, which really just comes out to be 3 plus 3 plus 3, which equals 9/10. Or, and out in the real world, 9/10 could be the same as 90 hundredths, which 90 hundredths is really close to a whole number, or the number one. Go back to money. This has nothing to do with money. This is talking about, parts of a pizza pie that they ate. But if I could estimate this and put it together, and I'm ending with 90 hundredths as my estimation answer, then I could think, well, 90 hundredths is kind of like 90 cents. And 90 cents is really close to that dollar. So I feel like the best answer choice is going to be A, because they really, if they're all eating that amount, the other ones just don't make any sense, honestly. Like if you go through and you look, they didn't eat a half. That's 0.5 or 5/10. They did not eat 25 hundredths. Think about that. One person ate more than that, and there's no way it could be D. That's the smallest one. And so, kind of wrapping things up here on this last page, when you estimate or use benchmark numbers, really think about using mental math, friendly numbers, things that you could easily compute in your head, and then coming up with that best possible answer.